Science and Space Exploration Satellites, * Windows to the Universe, * Introduction, *, for as long as humans have existed, we have lifted our eyes to the night sky in wonder. The stars, the planets, the mysterious glow of distant galaxies, all of them calling us to explore. For centuries, astronomers used telescopes on Earth to unlock the secrets of the cosmos. But there was always a limitation: our own atmosphere. The shimmering waves of air blurred the stars, hiding details and blocking much of the light that the universe was trying to send us. Then, humanity found a new way to see beyond the veil, by sending telescopes into space. Far above Earth's atmosphere, we opened a new window into the universe. Free from distortion, these space observatories could capture the cosmos in unprecedented clarity, revealing beauty and mysteries that had been hidden for billions of years. In this journey, we'll explore 4 of the greatest scientific satellites ever launched: the legendary Hubble Space Telescope, which gave us breathtaking images of galaxies and nebulae; the James Webb Space Telescope, the most powerful observatory in history, peering deeper into cosmic time than ever before; the Chandra X-ray Observatory, unveiling the violent and energetic side of the universe; and Gaia, the star mapping mission that is building a 3-dimensional atlas of our Milky Way. Together, these missions form humanity's eyes in space, each one designed to look at the universe in its own unique way. They are not just machines. They are extensions of human curiosity, tools that allow us to ask bigger questions about who we are, where we came from, and what lies beyond. This is the story of science and space exploration satellites, our windows to the universe. **** The Hubble Space Telescope, ***, on April 24, 1990. The Space Shuttle Discovery thundered into the sky, carrying with it one of the most ambitious scientific instruments ever built, the Hubble Space Telescope, named after Edwin Hubble, the astronomer who discovered that the universe is expanding. This telescope was designed to revolutionize astronomy. For the first time, humanity would place a large optical observatory, not on Earth, but in the emptiness of space itself. The reason was simple. Earth's atmosphere blurs and blocks much of the light from space. By escaping the atmosphere, Hubble could see the universe with unmatched clarity, observing invisible, ultraviolet, and near-infrared light. It was a telescope above the clouds, peering straight into the heart of the cosmos. But Hubble's story began with disappointment. When the first images were transmitted back to Earth, astronomers were shocked. They were blurry, unfocused. After $1 billion investment, the telescope's main mirror had a flaw. Only 2 microns wide, thinner than a human hair, but enough to distort its vision. The media mocked it, calling Hubble a failure. Yet, failure was not the end. In 1993, astronauts aboard the shuttle Endeavour embarked on one of the most daring repair missions in history. They installed corrective optics, glasses for the telescope, and Hubble's vision snapped into focus. From that moment on, the telescope began delivering discoveries that would change our understanding of the universe. With its sharp eye, Hubble measured the age of the universe more precisely than ever before, about 13.8 billion years. It revealed that the expansion of the universe is accelerating, driven by a mysterious force, now known as dark energy. It confirmed the existence of supermassive black holes at the centers of galaxies, invisible monsters shaping the fate of stars. And then there were the images. Who could forget the towering pillars of creation, clouds of gas and dust where new stars are born, or the breathtaking Hubble Deep Field, where the telescope stared into a tiny patch of sky for days, revealing thousands of galaxies in what looked like empty darkness. Each image was not just data, it was art, it was history, it was a glimpse into time itself. Over the years, astronauts visited Hubble for more times, upgrading its cameras, repairing its systems, and extending its life. Each mission turned Hubble into an even more powerful instrument. keeping it at the frontier of discovery for more than 3 decades. But perhaps Hubble's greatest legacy is not just in the science it produced, but in the way it touched humanity. Its images have appeared in textbooks, museums, documentaries, and even in music and film. They have inspired children to become scientists, artists, and dreamers. Hubble reminded us that the universe is vast, mysterious, and beautiful, and that we are a part of it. Even today, long past its original mission, lifetime, Hubble continues to orbit 550 kilometers above Earth, still watching, still exploring, side by side with newer observatories like the James Webb Space Telescope. Hubble remains one of the greatest scientific instruments ever created. Is more than a telescope. It is a time machine, a storyteller, a silent witness to the grand story of the cosmos. Asterisk, asterisk, the James Webb Space Telescope asterisk, asterisk. On December 25, 2021, while much of the world celebrated the holidays, another kind of miracle unfolded in French Guiana. A powerful Ariane 5 rocket lifted off, carrying with it a golden telescope, unlike any ever built. Its name was the James Webb Space Telescope, or JWST, the long-awaited successor to Hubble. JWST was the result of decades of vision, engineering, and persistence. Originally planned in the 1990s, its development stretched over more than 20 years, costing nearly $10 billion. Thousands of scientists and engineers from NASA, the European Space Agency, and the Canadian Space Agency worked together to make it possible. Some even called it the most ambitious space science project in history. Why so ambitious? Because Webb was not designed to simply continue Hubble's work. It was built to see deeper, farther, and older than ever before, with a massive 6.5-meter, gold-coated mirror. Nearly 3 times the size of Hubble's, JWST could collect far more light, and instead of orbiting close to Earth, it would travel 1.5 million kilometers away to a location known as the second Lagrange point, or L2. Here, Earth and the Sun's gravity balance, allowing Webb to remain stable, shielded from the heat of the Sun, Earth, and Moon. Asterisk. But getting there was only part of the challenge. JWST was too large to fit into any rocket. It had to be folded like origami, packed tightly for launch, and then unfold in space, a process so complex it was nicknamed the 29 Days of Terror. Engineers had to deploy its 5-layer sunshield, the size of a tennis court, and then carefully unfold its 18 golden mirror segments. If even one step failed, the entire mission could be lost. But against the odds, every mechanism worked perfectly. By January 2022, JWST had fully deployed, aligned, and cooled down to the icy temperatures needed to observe the cosmos in infrared light. Infrared was the key. While Hubble sees, primarily visible in ultraviolet light, Webb was designed to peer into infrared wavelengths. This allows it to see through cosmic dust and to detect the faint heat of ancient galaxies, formed just a few 100 million years after the Big Bang. In effect, Webb is a time machine, looking back more than 13 billion years into cosmic history, and when its first images were revealed in July 2022, the world stood in awe. The very first deep field image, capturing thousands of galaxies in exquisite detail, showed cosmic structures we had never seen before. It was like looking at a treasure chest of the universe's earliest secrets. Since then, Webb has begun to transform astronomy. It has studied the atmospheres of distant exoplanets, detecting water, carbon dioxide, and other molecules, clues to whether these worlds might be habitable. It has unveiled the dazzling birthplaces of stars, like the Carina Nebula, where colossal clouds of gas and dust are sculpted by radiation and winds. It has observed our own solar system too, taking stunning infrared images of Jupiter's swirling storms, glowing auroras, and faint rings, and even studying icy moons like Europa. Perhaps most exciting, Webb has provided evidence of the very first galaxies, shining faintly across cosmic time. For decades, astronomers wondered how soon after the Big Bang the first stars and galaxies formed. Webb is now giving us answers, showing us cosmic dawn, the moment when the universe first lit up. But beyond the data, JWST represents something greater. It is the product of international cooperation, a symbol of what humanity can achieve when we work together. And it carries on a deeper legacy, the quest to understand our place in the cosmos. Are we alone? How did the universe begin? What is our destiny among the stars? Today, the James Webb Space Telescope continues its mission, a silent giant at L2, orbiting the sun in perfect balance, sending back treasures of light that left their sources billions of years ago. Each image reminds us of the vastness of the cosmos, and the miracle that we are here to see it. If Hubble opened our eyes to the universe's beauty, Webb is taking us back to the very beginning, letting us witness the birth of stars, galaxies, and perhaps even the seeds of life itself. It is not just a telescope, it is the next chapter in humanity's greatest story, the story of our universe. Asterisk, asterisk. The Chandra X-ray Observatory, asterisk, asterisk. When we look at the night sky with our eyes, we see stars shining calmly. But the universe also has a darker, more violent side, one that cannot be seen in visible light. Exploding stars, black holes devouring matter, galaxies colliding in cosmic chaos. To witness these extreme events, we need to look at the universe in X-rays. That is the purpose of the Chandra X-ray Observatory, launched on July 23, 1999. Aboard the Space Shuttle Columbia, Chandra was placed into a highly elliptical orbit, carrying it a third of the way to the moon at its farthest point. From there, it could avoid Earth's atmosphere, which blocks X-rays from reaching the surface. While this atmosphere protects life on Earth, it also hides an entire universe of high-energy phenomena. Chandra was built to reveal it. Chandra's design was unlike any telescope before it, because X-rays pass through most materials. Ordinary mirrors cannot reflect them. Instead, Chandra uses specially crafted mirrors at very shallow angles, gently deflecting X-rays onto its detectors. The result is extraordinary, the sharpest X-ray vision of the cosmos ever achieved. With this vision, Chandra opened a new window on the universe. It revealed the spectacular remains of exploded stars, such as the Crab Nebula, glowing with the energy of a rapidly spinning neutron star at its center. It showed us black holes, not as invisible voids, but as engines of destruction, producing enormous jets of superheated matter that stretch for thousands of light years. Chandra also helped solve cosmic mysteries. By studying clusters of galaxies, it provided some of the strongest evidence for dark matter, the invisible substance that makes up most of the universe's mass. One of its most famous observations, the Bullet Cluster, showed galaxies colliding, with hot gas separated from the unseen dark matter, proving that dark matter is real and not just a theory. Chandra's X-ray eyes, also, revealed the turbulent regions at the hearts of galaxies. It showed how supermassive black holes influence their surroundings, blasting out energy that can shape the growth of galaxies themselves. It mapped shock waves rippling through intergalactic space, like sound waves echoing across the universe. But Chandra is more than just a tool for extreme science. It's also a storyteller of cosmic violence. Where Hubble shows us beauty, Chandra shows us power. It reminds us that the universe is not a quiet, static place, but a living, dynamic one, full of birth, death, and transformation, even more than 2 decades after its launch. Chandra continues to operate, working alongside Hubble, Webb, and other observatories to give us a multi-layered view of the cosmos. Each telescope reveals a different piece of the puzzle: visible light, infrared, ultraviolet, X-rays, and together, they give us a fuller picture of reality. Chandra's discoveries prove that to understand the universe, we must look beyond what our eyes can see. in the high-energy glow of the universe is alive with explosions, collisions, and forces beyond imagination. It is a reminder that the cosmos is not only beautiful, it is also powerful, violent, and endlessly fascinating. Asterisk, asterisk, Gaia, asterisk, asterisk, if Hubble showed us the universe's beauty, and Webb reached back to cosmic dawn, then Gaia, a mission of the European Space Agency, brought us closer to home by giving us the most detailed map of our own galaxy, the Milky Way. Launched on December 19, 2013, Gaia was placed into orbit around the L2 Lagrange point, the same stable region where the James Webb Space Telescope now resides. But Gaia's task was not to capture dramatic images. Instead, it was built for something equally extraordinary. Precision Measurement. Gaia is essentially a galactic surveyor, with its twin telescopes and billion-pixel camera system. It measures the positions, motions, and brightness of stars with accuracy never before imagined. How accurate? Imagine standing on Earth and being able to measure the width of a human hair from 1,000 kilometers away. That is the level of precision Gaia achieves. The result has been breathtaking. Over the years, Gaia has created the most detailed 3D map of the Milky Way ever made, charting the positions of more than 1.8 billion stars. Not only where they are now, but how they move, how fast they travel, and where they are going. It is like watching our galaxy come alive in motion. This dynamic map has revealed extraordinary insights. Gaia has shown us the Milky Way is not static but constantly evolving, shaped by mergers with smaller galaxies. It has traced the paths of stars that originated outside our galaxy, evidence of ancient collisions billions of years ago. Gaia has also expanded our understanding of the future. Its precise measurements allow astronomers to simulate how the Milky Way will interact with its nearest giant neighbor, the Andromeda Galaxy. Billions of years from now, the two galaxies will collide, merging into a new cosmic giant. Thanks to Gaia, we can visualize that future today, beyond stars. Gaia has also discovered exoplanets by detecting the subtle wobbles of their parent stars. It has tracked asteroids and comets in our own solar system with unmatched detail, and it has even identified distant quasars, super bright objects powered by black holes in the far universe, helping anchor our cosmic map to the deepest reaches of space. But Gaia's true gift is perspective. For the first time, humanity can step back and see our galactic home not as a static star chart, but as a living system. Stars dancing, clusters moving, galaxies colliding. It is a grand ballet of cosmic motion, and we are a part of it. Like Hubble, Webb, and Chandra, Gaia is more than a machine. It is a bridge between curiosity and knowledge, between imagination and reality. By charting the galaxy with such precision, Gaia reminds us that even though we are small, we are deeply connected to the vast stellar family of the Milky Way. It shows us not only where we are in space, but also where we are headed on our long cosmic journey through the stars. Asterisk, asterisk, conclusion, asterisk, asterisk, from the moment we first gazed at the stars, humanity has sought to understand its place in the cosmos. The journey from ground-based telescopes to space-based observatories has been one of our greatest scientific triumphs. The Hubble Space Telescope gave us visions of beauty and wonder, galaxies, nebulae, and the very age of the universe. The James Webb Space Telescope now carries us further, peering into cosmic dawn, uncovering the first stars and galaxies, and studying the atmospheres of distant worlds. The Chandra X-ray Observatory reveals the violent universe of black holes, supernovas, and cosmic collisions, showing us that creation and destruction are bound together. And Gaia charts the grand design of our own galaxy, turning stars into a living map of motion and time. Together, these missions form more than just a collection of satellites. They are the eyes of humanity, extending our vision far beyond Earth. Each one looks at the universe in its own way, capturing light we cannot see with our own eyes. Visible, infrared, X-ray, ultraviolet. Piece by piece, they give us a more complete picture of reality. But beyond the science, there is something deeper. These telescopes are symbols of curiosity, cooperation, and hope. They remind us that we are explorers by nature, that no horizon is too distant, no mystery too vast. In a time when human challenges often divide us, the cosmos unites us. Every image from space is a reminder that we all share the same tiny planet, orbiting the same star, in the same galaxy, in an unimaginably vast universe. The story of space exploration satellites is not finished. New observatories will rise, each more powerful than the last, continuing the quest to answer the greatest questions. Where did we come from? Where are we going? Are we alone in the universe? As we look up, we are reminded that exploration is not just about discovery, it is about meaning. These satellites do not just study the stars, they connect us to them. They show us that we are part of a larger, cosmic story, one that stretches across billions of years and trillions of miles. And in the end, they remind us of a simple truth. The universe is vast, mysterious, and beautiful, and the adventure of discovery has only just begun. Asterisk, 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 the stars above us are not just distant lights in the sky. They are stories, written across space and time, and thanks to the eyes we have placed in orbit, Hubble, Webb, Chandra, Gaia, we can now read those stories more clearly than ever before. These satellites are more than machines. They are our companions in exploration, carrying our questions into the depths of the universe, and bringing back answers in the form of light. The cosmos still holds countless mysteries, but one truth is certain. Humanity is no longer just a species looking up at the stars. We are explorers, reaching for them. This is only the beginning of our journey. The universe is waiting. Asterisk,